chair this one, yeah?
Yes, I'll chair the session. Oops, με παίρνει. Βασίλης σου παίρνει. Έλα. Στο Lindsay's πιο μέσα. Ναι, μαζί του, εντάξει.
Does the clicker work?
What?
Clicker.
Ah. And we have to open the PowerPoint. I suppose it's working. I brought it.
Which one is it? This one?
I don't know. This is. Anyway, I sent you 3 of them. This is Alexis, yes, and another one. Go down. Yeah, that's the booking reference. Here, there should be one. There it is. Save. Save again. Open folder. Oops, the one is PDF.
Yeah, I think it should record to the main screen. Could we record that? We change that to platform. Is that the 3 there?
Mm-hmm. We start with this one.
Yeah, just so capture the main screen. I don't know if it'll actually
It will not capture. Yeah.
Can we read in? Which one's the first one?
This should be. Let me check. No, this is the last one. This is the first one.
Let's grab a seat.
PDF to PowerPoint.
PDF to PowerPoint, yeah. Is it worth that? Recording. Just see the screen.
Okay. Should we put all the slides in one? same template.
Okay.
Or not, wait. No, they don't. It absorbs the template. No.
Three stars. I wouldn't put too much.
Paste. Sure. Yeah. Okay. Okay. It doesn't work. Oh. It works.
Remember, we record them on the microphone. That's the only thing you see. Let's record them. Wave. That's good. Let's record them. I don't know what's going to happen to a PDF one.
It's okay.
You use the radio mic.
Don't know. Okay.
So radio mics.
Yeah.
This one's in there.
Yeah, I gave the first one, so.
Okay. So it's definitely broadcasting.
Mm-hmm.
Good. Wow. See.
Yeah, I'll see you later. So, after the joint session, I would like to welcome you in one of our parallel sessions, the academic stream. We are lucky today to have a lot of colleagues that are going to talk about their work, colleagues that I've been working or I have been recently introduced. Everyone has a specific area that he or she is engaged, so I think we will be more than lucky to hear what they're going to say. The first colleague is, we've known each other since the undergrad, is Dr. Milton Kandias. I would like to welcome him. He's going to be our first speaker. Okay, I'm used to having a screen in front of me, so I'm going to stay here. So today I'm going to speak about offensive OSINT, offensive both under the prism that we use it for offensive operations, red teaming, and offensive because, nice, I prefer that. And offensive because it is actually kind of offensive under the prism of privacy, and you will see. So, I have done my PhD. I have no idea. I don't know about technology. I'm useless. Okay, it's not working. or I can speak really loud, if that makes any sense. Okay, so my PhD is in security data science. I've got some training in psychotherapy in order to combine those areas and focus on red teaming. And right now I am an offensive security red teaming engineer with Fortune 500 company. I focus on OSINT, social engineering, post-exploitation, and physical. So we emulate the bad guys and we try to gain access to our employer. So what we're gonna... Nice. So what we're gonna discuss today is this outline. So we're gonna talk... So technology is making stuff really complicated today. Okay. So we're gonna see some stuff about OSINT, see some research results about narcissism, etc. Then combine these things with psychosocial characteristics and how we can exploit them, and then move towards phishing and how these things can be combined. And of course, the last thing we're going to discuss is why none of these things is legal and why this should never happen. So let's talk about open source intelligence. This is a definition. It's based on publicly available information. It has to be disseminated in a timely manner. Yada, yada, yada. Everyone knows about that. So we're discussing information that are available to everyone, and we're going to analyze this information to deduce more information about our targets. An example. This is a tool. It's now obsolete, but I just put it there because it's more beautiful than manual Python. So here you can see that we're crawling LinkedIn in order to gather information for our targets, which are anonymized here. Also, this is shady and not exactly legal according to LinkedIn. But this is what the adversaries are doing, so we have to emulate them. Another example, here is how we utilize LinkedIn's characteristics in order to gather information for our targets. And on the right is a great example of how we can have a false, fake sense of privacy, because this individual has hidden their surname, but on top you can see that even anonymized, they have their surname on the URL, so we can deduce what's their email by having some information about how the organization creates the emails. For example, it could be first name dot surname, first name dot the first letter of the surname or something, so we could create a huge email list and start targeting people. And this is another interesting example. So you can see that we have people describing exactly the technology stack of the organization. It's not my organization, so if you find where I work, which is not very hard because you've got, I can't say it, but you have the schedule in front of you. So it's not from my organization, those people. So you can see the technology stack, so start creating a profile about how they're working, what you're expecting to see inside, what you're going to use. Also, you're gaining extremely useful information, for example, in the last example, about what this person is doing, how they're doing it. So you have a full profile to create a pretext to call them. So call them, pretend to be someone else and elicit information, or make them even install some malware on their systems, gain foothold, and then pivot. So let's discuss how we can weaponize some OSINT. First of all, this is the first research. Everything is focused on the Greek Twitter community. We crawled 42,000 people's profiles, analyzed them under the prism of how intense they use the medium, how they connect with each other. I tried to hide the microphone to not cause you problems. So we studied under the prism of graph theoretic analysis and tried to deduce, create categories of how people use Twitter. And we had information from other research that this correlates directly with the personality trait of narcissism. So we created interconnection graphs
So all the research that I'm showing you was created in order to mitigate the insider threat issue, but with a proper reframing, is what we're going to discuss today. A proper reframing of the research helps us in offensive operations. So you could potentially start gathering data and creating these graphs about the employees of your targets. So if you work for a company, if you're consulting for a company, you could start gathering data on social media to start creating these graphs, so you can find very useful information about how to target them. There are some tools that already do something similar, but manual is always better. So we also studied targets under the prism of their professions. So the red dots, the red X's or crosses, who cares, is people working in IT, and this depicts how intensively they use the medium. So, and the green one is people who are artists, singers, something related to, you know, more artistic. So this depicts that computer science, computer-related professions use Twitter much more. So if you're going to find a narcissist among them, you have to have different thresholds. So according to our study, we created 4 categories: the loners, normal users, advanced users, and celebrities. These are the 4 categories. And according to the results, you could deduce with some probabilistic approach the narcissistic trait of the target's personality and create an approach, a pretext, to adequately target them. The next one is predisposition towards law enforcement. This could mean very few things in this context in the UK, but in Greece it means a lot. So we utilized that. We also crawled information from YouTube, and we had a twofold approach. So we had a domain expert saying, categorizing comments as negatively predisposed towards law enforcement or positively predisposed. And then we got machine learning to decide on every comment from our data set, which was 2 million comments, 200,000 videos, and 30,000 users. So we deduced information for every comment, from comments to videos, and from comments, videos, and playlists for users. Then we had another approach that we had all this, every single user's whole YouTube existence in one tuple, and we conducted flat data classification. So we were able to create buckets of users, either negatively predisposed or not negatively predisposed, and compare the results. So both results found the same 721 users. The flat data one found a little bit more. So this is a way to have an approach to understand a person's predispositions towards law enforcement. You have the method, you feed it with the new targets, it decides where they belong to, you can manually verify and then decide for a pretext. This depicts that both methods converge and they meet each other. So the next one is identifying the political beliefs. Again, not sure how this could be useful in this context, but in the Greek context it's also very useful. So we did the same YouTube data set that we got a domain expert to categorize comments in 3 categories: conservatives, radicals, or neutrals, and then conduct supervised learning to categorize the rest of the comments, and from those decide for videos, and from comments and videos for users. So the results depicted back in 2013 depicted 12% radicals, 48% neutrals, and 40% conservatives, which was really close to the vote polls of that period. Again, how do we weaponize that? We understand the political background of the target, so we know kind of what they believe, so we can form a pretext closely related to them. Also utilize what is also connected to that. And The last thing is the stress detection. So what we did here is to combine the results of back anxiety inventory, the BI stress test. We implemented it on Facebook. We informed users that we were running research. So we got the users to respond to the test. We also collected their data, anonymized them, and tried to correlate them. So first of all, we tried to make the machine decide what's happening. So unsupervised learning found out that there are actually 3 clusters of users, which are in reality 2, because the first one has very few people. So we ignored that. The other one, however, the second cluster had people with low to medium stress, and the third one had people with medium to high stress. So the machine could easily understand, deduce from now on people who experienced, at least in theory and according to our results, low to medium stress and medium to high stress based on their social media, specifically Facebook profile. And then we created 13 ad hoc metrics to study how these differentiate based on the results of the test. So the test has this specific test has an effect. It's studying the effect of stress a few weeks before and a few weeks after the date that it was fulfilled. It was filled. So we were able to study per week what's going on, and the machine created 7 discrete clusters of users. Some of them had information about people with, had included people with high stress, other included people with low stress, and we could observe people jumping from one behavior to another throughout time. So we deduced that it might be possible to deduce what level of stress a user is experiencing based on their Facebook usage. So if a user is highly stressed, might be a good target for phishing. So if you are an adversary, an advanced persistent threat with a lot of money and you don't care about privacy, legislation, and ethics, you can implement this approach and start targeting people based on their personality. So, how this works? An abstract, very generic approach would be that the first step is to start gathering information on LinkedIn, because on other media, people might not want to be found, but LinkedIn is created so as you want to be found. You want to be found, you want to be promoted for your profession and your job. So people struggle to be found. So we start with LinkedIn. We might correlate data from previous stolen successful operations, successful engagements, stolen data from the target, and start understanding OSINT a little better. So reframing what we have to do to get better results. For example, instead of focusing on only one name, company name, which we could start focusing on several different company names. Apologies. So we start gathering data, and then we analyze them on step 4. So we analyze means that we clean up, we understand a little better our target, the organization, what's the specific group of people that we're after doing, and then we continue this cycle. At some point, we have to finish gathering and analyzing data and move to the initial results that have to be one last time verified, analyzed, and cleaned up before being fed to the pretext analysis. So after this phase, for example, this phase number 4 and 5 could be what I already shared with the results, the research results. So we could feed all the company people in an algorithm, all their data, and find the narcissists, and see how they relate to each other. Or if they are indeed ranking very high to narcissism, we could start creating pretexts about this personality trait. Or if they rate very high in radical or conservative political spectrum, target them according to their political beliefs. And the last phase is to actually write those pretexts, verify, see how they work, maybe do some A/B testing with some lesser targets before you create the big one, spear phishing, to the very important people. So let's dig a little bit deeper. What else can be done? So all these psychosocial characteristics have already been correlated to social media usage. So this 6 and 7, the citations here, these are just a tiny fragment of the research in this area. So we have the big 5, which is openness, conscientiousness, I can't pronounce that, sorry, extraversion, agreeableness, and neuroticism, who directly correlate to some characteristics of social media usage. Also the dark triad, which is narcissism, Machiavellianism, and psychopathy. And right now, there is this category called psychographics, which is a service being sold in the States, and you can actually count and have metrics on stress, depression, happiness, how insecure, how persuasive, how adjusted, impulsive a person is, at least a social media persona is, have results on their health, what food they like, what leisure they prefer, what work they would like to do. So for example, for work, you could, for example, be a recruiter, sending documents with job descriptions. And maybe they have to enable content and gain access to their system. So this could be a pretext that might or might not be used in the past. Religion and politics orientation. There are companies actually selling this as a service. So this is done. There are algorithms to achieve that. There are ways to implement and get this information. So let's see some correlation examples. Again, we're touching a soft science, so it's not exactly causation. It's not hard, tangible science. It's a little bit softer. But again, it's some correlations that are of interest, at least in the context of the offensive operations that I am describing. So for example, let's see, extraversion has strong correlation with happiness and well-being. So you see a person, first case, you have an algorithm that can deduce this information. If you search for michalkosinski.com, you can see that he has already created tools that generate this information about yourself. So you can create those algorithms, you can generate this stuff. It's not impossible. But let's say that you want a more empirical approach. You don't want to spend so much money for your offensive operations. Okay. What you can do is you can assume, deduce, maybe have a gut feeling that someone is scores high in agreeableness, and then create a pretext relating to well-being. So click this link if you want to receive all the run a marathon, be healthy, eat healthy information, quit smoking, or I don't know what. So let's move to phishing. We've got all the information. We are ready to weaponize this information. We know about the personality and stuff. So this is very generic. I'm going to go very fast. We are the attackers. We have created the pretext email. It gets through the email gateway delivered. This is purely technical, how to get it delivered. So we don't care a lot. The first case is to harvest the credentials, so intercept them. No more old school copy-paste of pages. We have good tools that proxy public-facing pages like Evil, Nginx, and Modliska. So these are excellent tools. We have moved forward in this area. Or the other one is to send a malicious document or a click once application, get them to click it, install it, or enable content, lead to remote code execution, and then you're good to go. You have a command and control channel, and then you can pivot, find more information, go after your objectives. And the last, a realistic scenario that could have been generated with similar approaches. This is an email inviting an individual to an event that has Justin Bieber, Phil Collins, Green Day, and Kings of Leon at the same event. So this comes from pretexting and open source intelligence. I don't know. Someone likes all of them, obviously. So they are there. Do you want to join? You might be eligible for a free ticket. How you might be eligible? Not just the usual phishing approach, but you've got a specific corporate specific account, a corporate specific code that you have to enter in the page in the following page in order to find if you are eligible. So this page asks for your ID, your corporate ID, the password that we just gave you at the email. So it starts to look legit, and your password. So let's assume that the target was interested, got his or her credentials here. This is the next one. So what they would see would be this loading bar, loading and saying that we're calculating if you're eligible, and if you will soon know. I just wanted a few seconds to test some stuff on their browser. That's the reason why I had to make this load. And then this button appeared, download your admission pass. Oh, excellent, let's download it. Oh, no, it's destroyed. Maybe if I click enable content, that will be fixed. It's not fixed when you click enable content. I just gain access to your system, not your system, the target's system. Also, some jokes about YouTube's monkeys over there, because maybe we were targeting technical people, and the document could be anything. Okay, DD right now is patched, so you can't use it, but never know. Anything from oily objects, macro, or anything else. And the last one, is any of this legal? No, it's not. And thank God GDPR, it's not legal. And I don't think that there is any scenario apart from emulating adversaries that you could potentially use it to a very extremely limited and very ethically bound approach. So if you're emulating real-life adversaries, you have a very specific framework. You are being audited by everyone at your organization, and you are not using the full extent of the toolset that we just described, that maybe this is legal and ethical. But the bad guys don't care. Advanced persistent threats don't care. So the more realistic you have to go, the more intrusive and offensive you have to be. That's all. Thank you very much for your attention. I will be happy to answer any question. Sorry, didn't see you.
So, have you done any automation of your gathering of OSINT, and how effective has that been?
Yeah, I have tried to. So the question is if I have tried any automation on the gathering. Yes. If we have API like YouTube and Twitter, we can gather it via the API. LinkedIn doesn't have an API, so we have to use Python and Selenium to emulate a browser that does stuff. This is illegal, but again, adversaries don't care, so we have to emulate the adversary. It works well, not really fast, and you have to buy the premium account. Shall I answer also for the clustering part, for the machine learning part?
Yeah.
I have used it only on academic background, so I'm not currently using it in my job because it doesn't fit in our ethical framework. But for pretexting, what one could do legally is to get do a TF-IDF, so an algorithm to find what's the more important words for the target. So it's kind of anonymized, so if you do it for example, for 30 targets, and you have all their favorite words, you can form a pretext that will speak their language somehow and be ethical. Does it answer your question?
Yeah, it does. Yeah, thanks. The next one is the emotional state. You referenced the emotional state of the individual in terms of their profile activity.
Mm-hmm.
But obviously, in the future, potentially, that people could actually get feedback, facial recognition, and seeing what the state is. Do you see that as a future?
Yes, I see it in the future as a Black Mirror, if you know the series, as a Black Mirror approach in reality. I'm not sure if I'm positive or negative about that, but I see it, somehow it is coming.
It's kind of scary, you know, because I can actually see the actual reaction to the piece of information.
Yes. It is still utilized on cold reading or social engineering approaches that we have to approach someone that we don't know and make them provide us access to the organization without them wanting to. We still use those tools, this knowledge, but it's not automated, it's not pervasive, it's not, so focused and so powerful. It's one-on-one. You're very welcome, sir. Anything else? Yes, please. Yeah, let me go back there. Sorry. It's not only my accent, it's my ears too. So Come on. Yep, Mikhail Kozinski. He has nothing to do with Cambridge Analytica. Nothing to do with that. He was just researching the same area at the same time. You're very welcome, sir. Anything else?
I'd like to thank Dr. Milton Kandias. So from ways to social engineer, we will hop to another subject. We will go to multimedia security, and a colleague from Stirling University, Dr. Deepayan Bhowmik, is here to present his work.
Thanks, Nick. Right. So, can you hear me, right? Okay, that's fine. Thank you. Right, I'm going to talk about something slightly different, where we are hearing lots of talk about cybersecurity in general, phishing, and then other topics. And fortunately, my previous speaker talked about something interesting about harvesting data from social networks or available informations. So I'm going to cover something slightly different on the multimedia side, and also going to talk about fake news detection, so that that will be touching on the previous speakers, some portion. Again, who am I? So I'm a lecturer at University of Stirling in computing science, and I'm also cybersecurity research team lead for SIGSA. SIGSA is probably a number of you know about SIGSA, Scottish Informatics and Computer Science Alliance. So yeah, here you go. So probably I don't have to explain everything in this big picture, because a lot of these things are quite well known about different understanding of the cybersecurity related challenges. Only thing I would probably show around these things here, cybersecurity and privacy, and some of the social information sharing. So these are the areas, and how does that impact on the multimedia side, and whether that has got any impact in economically or in our life that we're going to see, and how we can prevent that by doing some academic research and turned on to industrial scale. So what is multimedia security? Let's think about this particular figure. This is quite familiar, right? So we have Netflix, Amazon Prime, YouTube. We have got everything. What do? we just put it on a server, which is typically a streaming server, and then we stream around in different devices, whether it is a big giant television screen, or whether it is our HDTV at our home, or whether it is a mobile device, everywhere, right? So what's the problem here? Nothing. But the problem is in the copyright and information theft. So this is the slightly large number of text here, but let's try to read it here. The copyright infringement is basically a huge, huge problem in the economy worldwide, and not only in UK. UK itself is a big problem. And digital media has surged this copyright infringement because in recent years, we get lots of access to the broadband and high-speed broadband. And there is a kind of intentions, or sometimes unintentionally, we like to stream videos, we like to watch movies, sometimes without paying it, right? Illegally. And torrent used to be a very big name. BitTorrent, probably a number of you actually heard of it. Of course, we rely more on the streaming services these days, but somebody uploads the content there illegally, and then we love to watch. Ofcom reports 32%, this is a staggering number, of all films consumed online were accessed illegally, which is a big number. Now, what's the impact? The creative industries employ 1.7 million people in the UK and more. It's 5% of the UK economy. When we say creative industries, it doesn't need to be only the post-production houses or the production houses. It involves people who are acting, who are writing scripts, who are singing, writing songs, etc. Everyone in the chain, they're impacted somehow or other. Some of the studies have showed the loss of billions in each year in the entertainment industry because of copyright theft. And that numbers are 160 billion US dollar in US and $278 billion in Europe in 2015 alone. And this is a bit old report. So it's the copyright theft equates a total economic loss of $1.2 billion, £2 billion in the UK, and this is much higher number today. So we kind of understand the scale of the problem. Now we are trying to think what might be a kind of countermeasure. We do that. In academic research, we try to explore different avenues. How can you stop that? One of the ways is called digital watermarking. And possibly you have seen watermarks on your currency notes. You don't see it normally, but when you take it under the light, you can see it. So this is the kind of a similar concept. You embed some sort of information or hide that information in your media. What is your media? It could be audio, it could be image, it could be video, or it could be text, right? And how do you do it? It should be invisible, which is the imperceptibility, robust, so that it kind of carries on, even though you are exchanging, your media is exchanging hands, and it should be secure. So, for example, this is one of the examples. So this is your original image, and this is your watermark information you like to embed somewhere here, and you do that, you don't see that. Why? Because we just make use of the algorithmic understanding and the understanding of the image content, and we spread it out, right? If you take the difference between the original image and the watermarked image, it's basically you can see the information is spread out in different ways in those areas which are not easily visible. What are you going to do? What we are doing it, we are trying to identify those pixels which are not usually visible. And this is very interesting this is kind of estimating the human vision, right? This is understanding of the human vision, where do we look? And for example, this is the kind of, we say, textured region. If you do anything here, if you include some information here, we don't see it. But if we do anything here, that will be more visible. And you can see the algorithms are trying to find those areas, where those areas will be. So in that context, I will bring up another human vision system model, which is called a visual attention model. So for example, when you're looking at me, or when you're looking here, our eyes and brain, it doesn't process all the information at a go. It gives priority, right? For example, there's a most likely chance you're giving priority at this point to me because I'm speaking, or here because something interesting on the screen. But there's lots of other informations are there, right? So informations are valuable, but we don't really want to do all the computations, or we want to intelligently hide some information there. So that's why we are taking care of something called visual attention model, which is computational visual attention mimicking the human vision system. And you can see, probably this is right? When you are looking at this image, so this is the attentive region, and so here, and so here. And what is something to do with the watermarking? We just use that. We say, okay, don't watermark in the attentive region. That watermark everywhere else. For example, if you have very high strength watermark everywhere in the image, it may distort the image. Okay? But if you have a low strength watermark, you can have a very nice image which is invisible, but the strength of the watermark when it carries along might be lost. So this is the midway, something like that. Okay, right. So coming back to that picture again, so what will happen if we do the watermarking here, and anybody who is streaming here that has got a unique identity of the ownership. And if somebody is saying that illegally watching somewhere, that can be traced back where it came from, right? Source, the origin of that illegal streaming, etc., can be found. And it happened in previous cases. The person who actually streamed or illegally streamed has been charged, and there has been lawsuits, etc. This is just to protect the economy. Okay, this is one of the way to do it. Okay. Now I'm taking this another level, something we are working very actively in the blockchain domain. Now, how many of you heard about blockchain? Right, quite a lot. But still, I just want to give you some sense here, what is blockchain, and then we'll move on to how multimedia security combined with blockchain can provide or can deliver a certain sustainable solution to the problem we have. So in the blockchain domain, what happens, you do not have a central server, and it came from this, have you heard about Bitcoins, the cryptocurrency? So probably a lot of you actually heard about cryptocurrency. This is kind of saying it's a distributed way of exchanging information which is much more trusted, and all the participants within the system has to agree when to authenticate something or not. This is, and those informations, every time there is a transactions happening, it comes as a part of blocks, and that blocks form a chain in which all the informations are being kept together. Okay, I'm not going in terms of very detailed about the blockchain. What I'm going to show is how one can use this for the multimedia security purposes. The whole point here, two things we want to protect. One, the copyright information, where it is coming from. And the second thing, we want to know whether the image has been tempered or not. Because the image tampering has created a lot of issues. Sometimes riots in different places. Sometimes it has happened with celebrity issues on a number of things. So two things coming together, fake image, fake news. Fake news will come back later, but this is how we're going to protect it. So in this structure, what we're trying to do, we're trying to get some information from this image and the copyright information from this image. We're going to put them together and watermark them. I've just shown a few slides back how we can hide the information along with the media, and we can put them back in the blockchain where all the informations are being kept. And number of times you are sending images from one person to another person, that informations are automatically being stored in the chain so that you can trace back where it is coming from, or if somebody has changed something or not. And on the other side, when you receive something, what options do you have? You can go back to the blockchain engine and try to verify the information. And also, you can verify the information whether that image, what you have received, has got integrity or not, whether this is a fake image or somebody actually crop and cut and paste something. Right, so This is what we get usually from our experiments. So you have the original image. I have done some watermarking here. So this is quite look like the original image. And here somebody actually tampered with. They have added some of the information. Some part of the image has been copied and pasted. And then after processing, we actually identified those regions where those information has been actually somebody tampered with. How do you do that? Something called a signal processing technique, signal reconstructions using compressive sensing. Okay, so this is just to give you kind of a brief understanding how does that happen. The way we capture images or the videos using our cameras, we take lots of samples, lots of information being stored. You can imagine 4 megapixel cameras, 5 megapixel, even 40 megapixel cameras are in the picture. So what are they? They're taking more information within a square inch, okay? So in this case, what we're saying, we don't need that many information because we have algorithms, we understand how information processing works, and we can reconstruct the same samples from 40% of the original sample like this, okay? And what happens, even though if we have 10% of the samples from the image, still we will be able to reconstruct something which is interesting to know. Now, this piece of information, if I use that as a watermark information and put that back on top of the image and hide within the image, if I can extract this information, and then I'll be able to reconstruct these images. And I compare with whatever I have received and what should be the original. If you compare them, well, boom, you can see the difference, right? So it looks like a magic, but it's really the signal processing mathematics which can help you to resolve some problems like that. Now, going back to these watermarking issues and these blockchain issues, as you can understand, we can really have system which we're also working on that can actually provide opportunity to a number of entertainment companies, a number of creative writer or creative producers who are individuals, a very solid and easy to access interface where they can store a bit of information, and using the technology, they can make sure their work are not being stolen. They are not stolen, and nobody is economically harming them. So we're trying to stop that and trying to empower their economic understanding. So these are one of the ways we are currently pursuing what best we can do. And some of these works are being discussed within the JPEG International Standards, which I'm also part of it. We're just trying to see how JPEG privacy and security can be more robust. By the way, JPEG, the image format we use day in, day out, .jpg extension or .mpg extension for the video. So these are the things going behind the scene. There's a whole lot of people around the world who are trying to work on these kind of technologies and trying to make much more simpler and in a standard way so that everybody can be benefited. Right, okay. Moving now, the other side of the coin, which is the fake news. I was talking about the image and video, which are quite visual. Now, coming back to the fake news part, which is quite text. Okay, so I've just picked up a couple of definitions from, say, the first one is from the Merriam-Webster dictionary. So what is fake news? All of us are aware of the fake news, fine, okay? So news reports that are intentionally false or misleading, they're fake. Fake news on online social media, as any story circulated, shared, or propagated which cannot be authenticated, okay? It also includes rumors, clickbait, propaganda, satire, and parody, as the truthfulness of the stories could often be unverifiable. Okay, so in the previous presentation, thankfully, the speaker told about a lot of things, how we can accumulate information. I'm going to the other side of the story. If I get that information as a genuine user, how can we verify them that this is trustworthy source? This is one of the recent research we're doing, recently published, and trying to see, using natural language processing, sentiment analysis, and machine learning, how can we develop a system which is easily accessible and then can give you some sense of understanding whether the news is true or false. And this is one of the data sets, example data sets, where what we did is taken to see what's the non-rumor tweets look like and what's the rumor tweets look like on the Charlie Hebdo incident. That's a back in Paris a shooting incident. What we can see here is, is quite interesting. When you see non-rumor tweet, there's no particular pops out information is coming out, but rather a mix of information other than this, the big one, because that's the event. What we're trying to do, we're trying to apply, say, TF-ID or other natural language processing information to extract the keywords and the frequency of uses those words, and trying to see, build a dictionary and trying to visualize here. But on top of that, we found there are lots of words in the rumor tweets are quite sentimental. It's kind of positively emotional or negatively emotional. And frankly, in the rumor tweets, you can see some negative emotional words are popping up again and again. Okay, so this is the big data is giving me this information, this observation. And when we do the research, we try to understand this purely more on the data, not only what machine learning throws us with. We're just trying to understand what it is. And then when we actually go through a different corpus, different events, this is some examples. You can see the positive emotions and the negative emotion scores. And then when you do the emotional ratio, in case of rumors, you can see the ratio is much higher compared to non-rumors. And that gives us a significant idea which direction we should go for when we try to detect fake news and trying to classify fake versus non-fake. And then, well, this is a combination of machine learning and natural language processing and the sentiment analysis put together. We create a feature vector, which is quite common in the machine learning community. The features are the words, the keywords we receive, the sentiment score we receive from the tweet, and then we combine them, pass it through the classifier. We try to use different classifier like traditional support vector machines or logistic regression or deep learning classifier, and try to see some answers are coming out or not. And this is what exactly we get. We get a better accuracy of prediction. I'm not saying we have solved the problem, because this is a very, very challenging problem and it's a very hard problem to solve. But we're just trying in a direction whether we can achieve something or not. This is kind of point of academic research point of view we are trying to see. So with that, I thank you all for listening to me for the last 25 minutes or so. Now, if you have any questions, I'm happy to answer. Thank you. Yes?
Would there be any way for the algorithm that you described to survive, for example, YouTube or Vimeo upload?
You mean the multimedia part or the text part?
The text part. Let's say that we want to enter some text.
Yep.
Yeah, that makes sense. The video, and then make it survive uploading to YouTube and Vimeo, the most famous one.
Uh-huh.
Would that work?
It would going to give you some confidence score, the comment you are trying to input, whether it is a fake or not. But the point you are trying to say is interesting. We also work in that way. We try to generate text from the image and video, the reverse engineering part. So you have the image content and the video content, we generate text from there. And then we try to match them together, whether they're kind of true description or not. Yes? Yep. Right, okay. If I understood your question correctly, so you have got rumor tweet and non-rumor tweet, and the point is whether we can verify them both or not. Sort of, it's a subtle difference, because if you're stating some fact, and there's kind of, sometimes it is difficult to understand whether the fact is right or not. There are some websites which is doing fact-checking information, right? But sometimes it is difficult. For example, if I say in Glasgow there is a huge lake, or there's Loch Lomond is in Glasgow, or Loch Ness, that is a fact. Now, to understand that fact is a huge task to do. So that is what we are trying to do, but it's a big thing. What we are relying on, what's the notion of whoever is trying to spread the rumor? Is this the understanding the psychology, and can we interpret and code that understanding in the algorithm so that that can give us some sense? Does that answer your question, or not really? All right, okay. Uh-huh. Yeah, we just want to identify whether it is a rumor or it is a real. That is what. Sorry? In this case, we are trying to find the sentiment of that rumor. Is it too negative or too positive? Okay? Yeah. Yeah. Sorry.
Perhaps feeding on from the last question there, you mentioned about the sentiment analysis and gave the example of the rumour versus non-rumour slides.
Uh-huh.
To help identify the rumour slides, you mentioned that there was a higher incidence of what you described as negative words
Yep.
or emotional words. So I'm not that familiar with this domain of knowledge, but is there a sort of like a recognised list of so-called negative and emotional words?
Yeah.
And I suppose, so that's the specific part of my question, but the more general one is, how do you therefore address the bias question?
Yes. Indeed, it's very difficult to do that bias question and to answer that bias, because the lexicon we use, this is a standard lexicon in English. A different researcher has developed over the years what are the negative words, what are the positive words, and in fact, we are looking into more details. What are the emotions attached to whether somebody is angry or whether somebody is sad, happy? From the words, you can understand that. Now, here in the preliminary work, we have done kind of binary classification, positive or negative, but we are trying to find the finer details. Now, what we are facing the problem, because lots of tweets or informations are quite similar because of the incident itself, it's very difficult to draw a line. And more information and more data set we get, we will be able to remove the bias. Yes, it is biased, not fully understood, but we're trying in that direction. Right? Yep.
Hi. Do you foresee any application of the multimedia blockchain in combating things like deepfakes, for example, or do we potentially need a different solution for those?
Yes and no. Multimedia blockchain, what we're trying to do, the blockchain part itself is the infrastructure. Because watermarking has been there in the research for a while, and some big companies, they have adopted watermarking-based solution, including YouTube does a fingerprinting-based detection, and there are some other, Philips used to have a big division on the watermarking. Now, the trouble with these things, if they're too much one central organization oriented or central party, that's nobody else will get access to. The blockchain can solve that problem, right? So that it is more easily accessible to individuals. But the other part is the technology, how to detect the fake news or fake media. The deepfake is the problem. And one of the ways is you can do it using this watermarking-based and compression sensing-based way. That's one way to do it. But it's not always necessarily the only solution. For the deepfake, which is generated using the deep learning network, we're trying to address the same problem using the neural network itself, and also the physical attributes sometime. So this is a kind of very active emerging research area which needs a quick solution because it's spreading too quickly. Right? Yeah.
What about the humorous approach? So how can you distinguish that an article is humorous, and do you find, for example, if they are exaggerating? For example, the Prime Minister, after leaving her, was always going to join a NASA project.
Mm-hmm.
Something like that. Because I've read in the related literature, they talk about
Yes, so that is the part of the emotional information we're trying to understand in finer details. Right? This one is kind of the broad categorization of positive or negative, but very recently, one of my students has worked on the, created a kind of polar graph, how each emotions like sadness, happiness, and excitement, everything is being mapped from the text input he's getting. And that is a possibility, yes, if that is the only aim to do, whether somebody is trying, if your algorithm is trying to find whether somebody is excited about something or not, this is the kind of similar way you can approach, yes. Yeah.
Processing speed.
Mm-hmm. Which part? If you're talking about the multimedia part, let's say huge. For the text fake news detection, they are very fast. Text doesn't cost a lot of processing. Yes, that is real time at this moment, but we do not have a huge data sets either. When we try to do the more data to be in, the time takes for the training purposes, which can be done offline, which can take up to 6 to 8 hours for, say, 18,000 different articles we have. But when you do the test, like you have received a single piece of information or an article, and then pass it through the classifier, that is in real time. But the training is, yeah, that takes a lot of time and computationally expensive.
So, because we have to keep up with time, I would like to thank Dr. Deepayan.
So from the multimedia part, another colleague joins, Dr. Alexis Mylonas from Bournemouth University, and he's going to enlighten us about what we did last summer.
Is the mic working? Yeah, okay. So we've sorted the mic. The clicker is working, okay. Right, okay, so I'm Alex. First of all, thank you, Nick, for the invitation. I'm very glad to be here and see some familiar faces that we used to be in the same building a couple of years ago, and we haven't seen each other for ages. Right, so a bit about myself. First of all, I know that I'm the only thing standing before lunch, so I will make it as soon as possible so we can go and eat. So I'm with Bournemouth University. I'm currently leading the cybersecurity and forensics pathway. In the past, I have a master's from ISG. I have worked in the industry, and I'm really interested and active in the web community, and in particular with the OWASP project, if you know it. Right, and now the academic kicks in, and if you go out from this lecture, this is at least one of the slides that I want you to remember. Okay, the web is a nasty place. Okay, because you have red team ninjas operating there, grabbing our data, and you might think that, okay, yeah, I don't care. I'm secure, I don't have anything to hide, or I don't go to bad websites. I don't do porn. I don't go to get cracked software. I'm not online gambling and stuff like that. So I am secure. As you probably know, or as you have heard from, at least from Miltos today, you are not secure, okay? Because the bad guys are actively hacking websites. This is called watering hole attacks, and they are adding malicious content that is grabbing your data or is grabbing your systems, okay? Today we're talking about tracking, and can this get worse? Yes, of course. We spend at least, the statistics say that we spend at least 1 day per week online, okay? So we are exposed to these threats at least for 1 day every week. And for the past 5 years or so, the device that we are using to access the web is not the PC anymore, it's the mobile device. Mobile device is not the mobile phone, it's the tablet, the smartphone, it's the smart devices that we all have, smart TV, or what have you, smart something. And maybe the second thing I want you to remember is that whenever you hear the word smart, in my mind, you should think vulnerable, okay? Right, so this started towards the end of my PhD. So I was thinking about, okay, well, my PhD was about smartphone security and privacy. So I was thinking, okay, we are spending so much time with this device, the smartphone, which to me doesn't sound so much secure in the other context that I have studied. Let's see what is happening with web, with threats like that. So I started actually testing browsers for desktops and smart devices. And this is a summary of my results. So 5 years ago, when these devices were the device for accessing the web, most of the controls that you love in desktop, like safe browsing to filter malicious and phishing sites, controls that are blocking, tracking cookies, private browsing, and the like, DNT, do not track me, and stuff like that, were not implemented in all the browsers that you had for Android, iOS, and what else we had? We had Windows Phone at the point. Now they are not there anymore. And we also had a lot of usability GUI issues with their configuration. A few years later, we focused on the safe browsing, on the filtering technologies that you have, safe browsing and smart screen. This is the first line of defense that you have against malware in your browser. And we found that the protection that you are actually getting in the smartphone is very, very low. In April 2016, we found that private browsing is not private at all, because you can you can get data from the browsing session even without forensic techniques. So we're not talking about recovery of data from the file system. And now we are getting towards the main topic of this presentation, which is tracking. And last year, we found some new tracking vectors, okay, which are actively used by trackers to get our web browsing history. Right, this is another slide that we used to teach together in Greece. This is 2007, I think, right? The session is recorded, so I cannot say some of the stuff that I would like to say, but there is this article from 2012, so 4 years from 2008, which says that, you know, guys, today I went to New York Times and I'm tracked by 100 trackers. This is what this journalist is saying here. So we are living in the post-Snowden era, okay? And this is actually one test I did when I presented a similar presentation for WASP London in November 2018. Okay, last November. Okay, so basically this is 5 minutes browsing. I wanted to, well, this was the Black Friday period. It was November, so I actually bought a TV, so I went to Paris. I also wanted to book a place to live, to stay in London, to present in the London chapter. This is me taking my favorite basketball team and the BBC. This is 5 minutes browsing in a clean vanilla version, vanilla browser that I just installed for the purpose of the test. And I have 152 trackers in 5 minutes. This is, by the way, a very nice add-on by Mozilla that you can actually visualize your own trackers. And this is more recent. So the New York Times have started discussing about privacy. If you Google, they have some articles about location privacy, about tracking. And I think in February, around February they started the privacy project, which has one aim, to educate us, to spread the awareness about privacy online. Okay. The funny part is that the privacy project has 100 blockers, trackers on it. Okay. So when I tested yesterday, I had 20, but my browser is automatically filtering some of them. The good thing is that today, most of the anti-tracking, okay, is the by default option. Okay, so 1 year ago, I think Opera started this, let's say, battle against trackers. They said, from now on, by default, all our users will have anti-tracking by default on. This has been followed by Firefox recently. And sadly, I recently heard that Chrome is breaking all the ad blockers. Okay, and unless you pay extra premium, you cannot have anti-blocking capability. Again, we are recording the session, but Google is earning money from this technology, so this is not a surprise for me. Anyway, tracking is not always evil. Okay, you might want to track your users in order to improve your website. You might want to do analytics and improve. But tracking, in my book, is malicious when it gives you a window to your personality, and it can also give you access to data that you don't want to share with others, or you don't understand that you are sharing with others. And these data are very useful for hackers, red teamers, okay, in phishing scenarios, and not only. Again, we don't have the time to. If I start talking about tracking and security and privacy, we can stay here for 3 hours. But this is 2 questions for you. Think about it and decide on your own. Do you prefer to have irrelevant advertisement when you're browsing, or are you scared when you get a personalized advertisement? Okay. Right, tracking technologies. So this slide summarizes the options that they had actually, the trackers historically, when we consider data being stored on the browser. Okay, it started with cookies. Okay, I think cookies are well understood, and it's well known that are being used actively for tracking. And well, cookies have a lot of limitations. Okay, it has very limited storage, but the most important problem is that people know about it and they clean them. So the trackers and the attackers have, the trackers have moved on to other technologies that give more benefits in storage, and they're less known, especially when they appear. So they started using plugins, extra software being installed in the browser, like Flash, So we had flash cookies, Silverlight cookies, and stuff like that used for tracking. And then the next step in the evolution of storage APIs for browsers, in the browser ecosystem, is HTML5, okay? Which gives you JavaScript capability to store stuff on the browser. A little bit of note, there are other technologies that can be used to track you, like fingerprinting the browser, the headers, the HTTP headers that you are providing to HTTP requests. You have web beacons, but from now on, we are only talking about tracking that is using data that are being stored on the host. Right. If we think about HTML5, you have three options to store data. You have web storage, web SQL, and IndexedDB. Web SQL is deprecated, and it's recommended not to be used. Some of the browsers have kicked the technology out of their ecosystem, like Firefox. Others don't, like Chrome, Opera, still allow you to use web SQL to store data in your browser's clients, okay? The interesting thing about these technologies is that when we started this academic research about whether they are used for tracking or not, and this is an MSc project that we did last year. The funny thing was that we searched in the community, we searched technical reports, we searched academic papers, and we found that these technologies were believed not to be used for tracking. Which, if you think about it, if you consider the history of tracking, this is very weird. It's very weird that you have a technology that is new, fairly new, that people don't know about it, and it's not used for tracking. However, the specifications say otherwise. They say that these technologies should be treated as cookies. So you have to enable the users to know about their existence and allow them to delete the data that are being left on the client for obvious privacy reasons. Okay. So we said with the MSc student, my MSc student is Stefano Belloro. If you read regularly the BBC, he's the technical manager in the BBC in multiple languages. So depending on what you are reading in the BBC, he's contributing there, or his team, okay? So we said, okay, this doesn't seem right, let's test it. And this is what we did. We tested only two elements, let's say. The frequency of the use. We wanted to see whether these technologies were used, in particular for web SQL, which was deprecated. And then the most important bit, as you can imagine, is, are these technologies used for tracking or not? Okay, is what the community and academic research correct or up to date or not? So basically what we did, we collected, we got data from websites that we are using, the top 500,000 sites that we are using, and we did static analysis, and we identified trackers in this data that we have in the data set. To identify the trackers, we used DNS names that we knew that were frequently used by trackers, and we used the three most popular blacklists, like Disconnect Me and others that you might have seen if you are using AdBlock Plus or another anti-tracking technology. Well, this is the architecture. It's not very important, but let's jump quickly to the results. How much time do I have? Okay, right, I will. So basically, these technologies are used as a third-party sub-resource, which is not surprising. But what is the most interesting result here is that the newest technology is the most frequently used, but also that this deprecated technology is still used in 1% of the top sites that we are using. And what is even more interesting is that tracking is their main use. Even for the deprecated technology, half of the time, this technology is used to track us, okay? With regards to the most popular technology, 7 out of 10 times, this technology is used for tracking. The main use case of the technology is tracking. It's totally opposite of what we knew at that point that we did these tests. We found out that, as you might expect, that very frequently websites would have at least one tracker using these 3 technologies, okay? And with regards to web storage, this is almost 6 times out of 10. So we said, okay, we were wrong, okay? Now we know something new, okay? The trackers are using these technologies. Let's see what we can do against it. So the obvious thing to do, as in the cookie tracking mechanism, is to delete them, right? So we tested the popular browsers for Windows, macOS, and iOS, Android, and Windows Phone, okay? These were the browsers that we have tested, and we checked whether we could delete the data that the 3 technologies that we are talking about were storing. To do that, Stefano wrote an application. This is available online. There is an even more, let's say, user-friendly URL in the end of the presentation if you want to actually test your browser. Okay. And the results are not very encouraging. Okay. Firstly, we found instances where you cannot delete data at all from these technologies. And here we have to consider that when I say we cannot delete them, obviously I can delete my data, okay? My phone might be rooted, and I can write a script and delete the data. I can open the database and, worst case scenario, sanitize it, or I can do something about it. But if you think about users that are not technically and security savvy, we have a big problem here. Okay, the browser cannot help them protect against trackers. Okay, the second problematic finding was that in some cases, the browser might ask you to do an extra step in the GUI. In my opinion, extra step in the GUI is this step will not happen. Okay, and when I say the browser, if we think about who is using Android and Firefox, if you are in this case, no, it's only me then, you have this problem. Okay, you need an extra step in the GUI, which is not easy to find. And why is this important? Because the fact that you cannot delete this data means that the attackers can create zombie cookies, or they can use a technique which is called as cookie resurrection. Okay, and I will probably give an example for that in the next slide. So if you have one of these browsers in one of these devices, then let's get an example. So if you are using Android and you were using at that point Firefox 60, then if you try to delete IndexedDB and web storage, by the way, you cannot delete or store anything with WebSQL because I said this deprecated API is not available in Firefox. Okay, so for Firefox, you only have 2 options with regards to storing data. Okay, so basically, let's say that you have a tracker that is, you visit a website that has as a third-party sub-resource a tracker, and the tracker is installing data, okay, with IndexedDB and web storage, okay. If you set the browser to, if you try to delete the data with Firefox in Android 8, you will delete the web storage content, but the IndexedDB will stay back. Why is this a problem? Because the tracker, the next time the next time that the tracker finds you, will resurrect the web storage content with the IndexedDB that was left back. And if you think about it, we have a spectrum of technologies. It's not only about these HTML5 technologies. If there is one technology that is left behind by the browser, if you have cookie, flash cookie, web storage, and IndexedDB, and the browser deletes everything but IndexedDB, the next time the tracker finds you, then the IndexedDB will be used to resurrect all the data for these 4 technologies that I mentioned, and the tracker will use the functionality for each technology that corresponds to its functionality or whatever goal the tracker has. And when you delete them, this will be left back, and it will be resurrected, and it goes on and it goes on. Right. Let's see what happens with private session. So the private session is promising us to not store data while you're browsing. Okay. What we found was that private browsing is not private, okay? Because you can still have data persisting a private session after the session is destroyed, or even worse, you might have private data being leaked to normal sessions, to sessions outside the private session. And this is the summary of the cases where this happens. So again, with Android, if you have Opera 46.3, IndexedDB and WebSQL will remain a private session, but only web storage will be deleted. Again, the same problem, cookie resurrection, and obviously privacy violations. Right. Now, we have been working with the OWASP community and the browsers. Hopefully, most of these problems have been fixed. What is interesting is that, okay, most of the bugs have been found and have been patched, but the problem is that most users might not have access to the updates. Okay, most recently, most users do not have access to updates because of what is happening in the other side of the pond, okay? If you have a Hawaii phone, you know what I'm talking about. Other users are not bothered to install updates. And what is very interesting, and what we can confirm with this study, is that the bugs that we have submitted and reported multiple times appear and reappear in subsequent versions. So here, I'm talking about Opera 46. I think the current Opera is 49 or something like that. In subsequent versions of Opera, some vulnerabilities were fixed, and then in the next version, some vulnerabilities were appearing again, and it seems to us that we are kind of in the mercy of developers, and it seems that maybe the patching strategy is not consistent. Right. If you want to test your browser, hopefully all these vulnerabilities have been patched. The only thing that still remains is the Firefox bug, as far as I remember. Please, if you find that your browser is still vulnerable, please contact me or contact the vendor if you want. I mean, you can contact directly the browser. This work has been submitted and it's available in this journal. It's open access. We have been working with Firefox for the past year on privacy. especially on their tracking mechanism that has been recently introduced. And if you have any questions, I'm happy to answer them now, or you can email me later. Thank you. Yes.
Does factory resetting a phone or just scrubbing your hard drive exactly with this residue?
If you scrap your, when you say scrap your disk, what do you mean exactly? If you format the, yes and no. Basically, when you are unless we are talking about secure deletion of data on the hard disk, all the data can be recovered. Most of the data can be recovered with forensic techniques. Okay, I don't think that the tracker cannot do something like that on your, as far as I know, okay? Because you need low-level, well, it's costly. This is the reason, not the low-level access. But I mean, formatting your disk to avoid this stuff, I don't think that this is the way I would go forward. If you ask me what I'm doing, I'm using multiple browsers. And if I really need stuff not to be written on the disk, you can set up a RAM disk, a file system that resides only on your RAM. And when you destroy the disk, shut down the machine, wait for 15 minutes, then the data are gone with confidence. Okay. Okay?
So, this is the end.
Lunchtime.
The first part of the academic session. We have an hour break for lunch. We will see you in an hour. Yeah, you should ask Alexis. Yeah, exactly. No worries. Hello.
How are you?
Good, how about you?
How was that? How was today? So far?
Until now, yeah, everything is okay. At least in this lecture theater. The other lecture theater has probably issues
Oh.
with broadcasting.
Okay, gosh, okay. I've seen actually broadcasting, live broadcasting was alright, you know, for this. So yeah, okay. So I was at board actually.
Okay.
Yeah, in the morning.
I know that's why Steph couldn't make it.
Okay. So, do you need help anything?
No, I'm good.
Afternoon. Petra is here.
Oh yeah, do you want to get you to have your presentation?
Yeah, do I need my laptop then?
What do you want to? You want to use your laptop?
Well, does it matter? Should be here, right?
Do you have a presentation?
Yeah,
A USB stick?
well, I sent it, but I don't know. Have it here
Who
already.
did you send it?
Nick?
Nick. Nick, it's just there.
There he is. Hello.
I'm Nick. Nice to meet you.
Did you have my presentation?
Bill, I sent his presentation to your email.
Right. Easier. I don't want to open up my email because it's broadcasting.
Okay.
Do you not have a copy of a USB stick?
Do you have a stick or should I?
I've got a stick somewhere.
Otherwise,
I can check if I have.
I can go to my bag. Okay. We found one.
Yeah.
Yep. Okay. Should I put it here or down?
Oh, then there.
Sure.
It's muted.
That's good. 1, 2?
Yeah.
Yeah.
Which one's the mute?
Here. Now it's muted.
Mute is which one?
Yeah, here.
1, 2, 1.
Okay. Will you make the announcement?
No, you do it. Can I just check the laptops?
Is there a clicker or how do I slide through here?
Oops. Sorry.
Yep.
So is it okay if I come up? Just before.
Okay.
Wait, okay.
Okay. This is going to be our last session in the academic stream. Then we are going to have again a joint session. We tackled a couple of subjects, so we are going to keep up with a more machine learning approach presented by Dr. Ariel Ruiz-Garcia.
Hi, everyone. Like he said, my name is Ariel Ruiz-Garcia, and I am a visiting researcher at Coventry University, and I'm also a machine learning engineer at Ariel. And I'll be talking about neural networks and more specifically generative adversarial learning. Just a quick overview of the presentation. I'll do a bit of intro into deep learning, and then I'm going to relate it to my own research on face detection and emotion recognition, then a bit of research on fingerprints, and then a bit of research in the biomedical field. Then I'm going to follow up by talking about guns and other applications and how they relate to adversarial learning, which I believe might be of interest to most of you. So I'm not sure if most of you have a background in machine learning or deep learning, but deep learning is sort of the popular go-to nowadays when we want to do some sort of classification or supervised or unsupervised learning. But before deep learning, we had other approaches in machine learning, such as support vector machines for classification, which are still quite popular, but it seems that everyone thinks that most problems can be solved by using deep learning, which is not always the case. And before deep learning, we also had shallow neural networks, and according to the universal approximation theorem, any function can be approximated using a shallow network of one layer. But in practice, this is quite unrealistic, because that means that to learn more complex functions, then we need to add more hidden units to that same layer. So deep learning does quite the opposite. Instead of adding more hidden units to one layer, we add more layers with more hidden units, and this lets us learn more complex functions. Some of the problems with deep learning are mostly that they require a lot of data to learn anything significant, and they are often difficult to train and are also very computationally expensive. Well, we now have GPUs, and that's probably why there is a lot more research going on in deep learning. A bit about my research specifically. When I was at Coventry, as a full-time member, I was looking into emotion recognition from facial expressions. But I'm not going to go into detail about that. I'm going to talk more about the difficulty in training neural networks and how this relates to adversarial learning. So one of the first things that I came up with was this architecture. And this was a few years ago, so it was quite difficult to train a neural network. We didn't have things like batch normalization, and this architecture will take about a month to learn anything significant. But the idea was that instead of making a deeper neural network, we simplify the learning of the network and split the image, because since I was working with facial expression images, then we could take advantage of that, because the faces are always going to be in the same place. So we can simply split the images into two, and then each network will learn specific features. One of them features around the mouth, and the other one around the eyes. And that will essentially make it easier. And we got some really good results with this after training this for about 20 days and about 20,000 iterations. So at the time, training was too difficult. So we tried to, there was another problem. When you try the same approach in a different computer, you wouldn't get the same results. And this was mostly because the way we initialized the weights of the network was a bit different. Every system will have a different seed for how we randomize numbers. So that made it a bit more difficult, and we decided to look into a better approach. And we came up with the idea of pre-training that CNN as a convolutional neural network. And essentially what we did was treat each individual layer of the network as an autoencoder and train that autoencoder. So an autoencoder simply learns what is known as an identity function, which essentially is it learns to replicate the input that you give it. So using this approach, we went from 20,000 iterations to about 70 iterations, and training was done in just a matter of a couple hours compared to a couple of weeks. And this also improved the performance of the network. But there was another problem now. The reconstructions of this model were quite different than what we expected. And sometimes they wouldn't even really look like an actual face. So we realized that the problem was the algorithm that we used to train, which is greedy layer-wise training. So we came up with a solution for that. And I'm not going to go into detail on this, but essentially it means that instead of training each individual layer and then putting them all together, we train one layer, add it to a stack, train another one, also add it to the stack, then train the entire stack and do the same. So that improved the relationship between those two layers or subsequent layers after. But then when we tried to test this model in real time, we got about 30% of accuracy, when on the training data or the training set, we were getting about 100% and about 97% on the testing set. So we thought, okay, so this is a big problem. Then we realized that the main problem was that the images in the training data were quite different to those that we got in the environment that we were testing it on. So we realized that, for example, those two images right there, they are the same images, except one has better illumination than the other. But for a neural network to know this, it's quite difficult. So it was telling us that these two images are two different people. So we decided to come up with an approach to train for illumination invariance. And we came up with this approach, which was essentially, instead of using the same image that we use as input and as the target for the reconstruction, we use an image with better quality. So essentially, the target image will have about 20 other images that are exactly the same, but with different illumination. So as you can see in the images at the left, the ones at the top are the input images, and the ones at the bottom are the reconstructions. So in some cases, even when you can't really see the face, the model managed to actually predict what that face looks like and retain all the important information, which in my case, for emotion recognition, was the shape of the eyes and the mouth. Then the ones on the right are the images at the top are also the input images, and these belong to a completely different data set, never seen by the model. The two images in the middle at the bottom are the reconstructions produced by our approach, and then the ones at the left were the reconstructions produced using the standard greedy layer-wise training method. So this brings me to generative adversarial networks, which are probably the most popular topic in machine learning right now. They basically learn by playing a minimax game between two networks, and although this became popular when Goodfellow introduced GANs a few years ago, something similar had already been done back in the 90s. But the nice thing about GANs is that basically we can generate anything from random noise. So given a random vector of noise, we can actually generate anything like a face or an image of a house, a car, whatever. And the idea is that they can actually imitate any data distribution. And because in deep learning, lack of data is such a problem, many people think that this is the way to go forward, because then we'll be able to generate our own data, and that will solve a lot of problems. But they are also difficult to train, and it is difficult to generate data with specific attributes. And more importantly, a big problem is that the generator model is prone to mod collapse, which means that it often only generates data with very few variations. So in my case, because I wanted to create something that works in real time and in unconstrained environments, then I created what I called a generative adversarial stacked convolutional autoencoder. So in this case, the model was actually trying to create a frontal representation of a face with some pose, facial pose. And so by doing this, when we try to classify that specific image, then the distribution and the search space for the classifier is a lot smaller. And in this way, we can actually see the details that we care about, which, like I said, are essentially the shapes around the mouth and the eyes. And the others are just some other layers that I developed to help accomplish this, but I'm not going to go into detail. So by doing this approach, as you can see in those images, the ones at the top are the input images, and then the ones at the bottom are the frontal representations of those images. And then by doing this, we also improve the performance of the classifier quite a bit. So going from initially about 30% accuracy in unconstrained environments, then when we did just illumination, we improved to about 60. And then by doing this and combining it with illumination invariance, we achieved 81%, which is an acceptable performance for a model in real time. These are a few other examples of the reconstructions produced by this model. And as you can see, most of the faces have about the same illumination and are looking forward rather than to the side. This is just part of the training algorithm. Then I jumped into deep reinforcement learning as well, but I didn't do much in terms of GANs in this case. I simply used the model that I implemented before for feature extraction. And the idea here is that having an agent transform a bounding box, which is placed randomly on the image, the agent will simply place it around the face, even if this is rotated. So this was actually quite good as well, and it managed to outperform the preferred choice at the time for face detection. But now we have other approaches like faster RCNN or SSD networks, which actually work on multiple faces. So in terms of fingerprints, I did a bit of work as well, which lets us estimate a person's age, gender, and just by looking at, well, not looking at, but just by analyzing their fingerprints. We also managed to tell specifically where that finger came from, whether it be a little finger, a thumb, left or right. We managed to do that. And we also managed to detect if a fingerprint had been altered in some way or another. So we use a generative adversarial network for this as well. And this one is on restoration of fingerprints. So as you can see at the one at the bottom, if the fingerprint was altered in some way, in this case obliteration, we managed to actually reconstruct it back to what it should look like. And then in this way, we can then identify an individual. It also removes scars and simply enhances the image if it doesn't contain any errors. Then working in the biomedical field, I did a bit of work in analyzing biomedical articles in the literature. And this was actually done to index those articles better and then facilitate searching for them based on the content that they had in terms of the images that they contain. So in this case, we simply created a generative adversarial network, which will tell us the location of the text within a figure in those articles. And there are many, many other applications. One of the most recent ones that I really, really like is someone came up with the idea that they can actually generate an image of a person simply by using a spectrogram of their speech. So essentially, by listening to someone speak, they can tell what they look like. And this is quite, in my opinion, it's quite amazing. And there are many other applications. These are just some of the most popular ones. And one that I also really like is video synthesis, in which people just try to generate random videos with a specific topic. For example, a music video, and there are even applications where they do, they compose music using this type of networks. But there is a big problem in machine learning, or specifically to deep neural networks. If you remember earlier, I said that the network couldn't tell the difference between the two images to your left. But when we add some sort of noise or alteration to that same image, like the image to the right, then the network somehow recognizes that person as someone in the database. So this is quite intriguing because face recognition and fingerprint-based recognition are becoming, well, fingerprint has been already for quite some time, but now face recognition has become, or is becoming, one of the main ways to identify someone. But as you can tell, these models are not very reliable. And another big problem that we have is that a lot of the benchmarks in computer vision are set by using pre-trained models. So models that were trained on a different data set. So usually there is a data set called ImageNet, which has about 1,000 classes, and is quite good at at learning, well, for the models trained on that, they're quite good at learning to extract different shapes or features that we want. But the problem is, so if these models are based on a pre-trained model and someone gets access to that pre-trained model, then they can easily reverse engineer what the second model is doing. And in this way, then we can sort of generate attacks to that specific model. And by having access to that original model, then that basically gives us half of the solution if we wanted to do an attack and try to fool that secondary model in any way. A couple of years ago in the literature, there were a few things that people claim will be better at defending models against these types of attacks. But in reality, they don't actually work. And the one that seems to be most effective is trying to train the model against a large number of possibilities of what an attack will look like. So for example, in this case, then we'll have to generate probably hundreds of variations of that same image with some noise added to it in order to tell the network that it is not part of that they are not the same image. But then if you have, say, 1,000 people in your database, then that becomes impossible. And realistically speaking, you'll probably have millions of faces in your database, so you'll never finish. So that is a big problem in machine learning, and I believe most of you have a background in security. So in terms of machine learning, this is probably one of the biggest topics when it comes to security. And just to summarize, it's a bit difficult to say this because I am a machine learning person and I've been doing deep learning for so many years. But deep learning is really not the solution for everything. Many times people try to solve problems using deep learning that actually require a simple solution, and sometimes even something like linear or logistic regression is good enough. And another thing to consider is that if we are trying to create an application based on deep learning, and this is to actually work outside of a development environment, then we need to take into consideration things like the complexity of the model, because we want it to be fast and effective. Then we also need to take into account the data that we use to train the model, because like I mentioned before, by having data with different illumination, that basically gave us a drop in performance of about 70%. And for more important applications or more sensitive applications, this is a big problem. So also to take into consideration vulnerabilities of the model against adversarial attacks, which, as I just mentioned, it's such a big problem, and at the moment we don't really have a solution for that, or we don't have anything that is actually efficient at defending a model against those attacks. And part of this is because we don't actually fully understand what those models are learning. We have an idea and can have a look at the weights of the model, and we can sort of see what shapes, if it is a convolutional network, we can see what filters are learned and what shapes they extract. But because realistically speaking, we're always going to have millions and millions of parameters, it's always going to be impossible to look at all of them individually and then all of them together to get an idea of what's actually happening. So that's one of the reasons why deep neural networks are often referred to as black boxes, because we don't really have a full understanding of what's going on. But if one day we actually manage to understand them properly, then that'll probably give us a new insight into how to defend them or how to make them less prone to such attacks. And also, this is just based on my experience, but sometimes replacing empirical error estimation functions like mean square error or absolute value criteria helps in, replacing them by an adversarial approach helps a lot in improving their performance. And if you are using transfer learning for your model or your application, just take into consideration the fact that it is very likely to be prone to adversarial attacks. And that's it from me. So if you have any questions. Well, if the perturbations are part of the training data, then the network will have seen them before already. So chances are they will be recognized. But realistically speaking, you can't really create perturbations that will cover all possible.
That's what I was going to ask, if there is any approach that kind of predicts possible perturbations, or you have to teach the system first?
I think you usually have to teach it first, and oftentimes you can train a model to be specifically trained to tell whether an image, in this case, has been perturbed in a way or another. But then again, that's just going to be dependent on the data set that you have, on the training data that you have. Anything outside of that distribution, the model wouldn't know what to do with it.
So, we'll go to the last talk of our session, which is going to be a bit longer. Professor William Buchanan will take over, and he will guide you through privacy and machine learning interaction.
that was Metropolis 100 years ago. It was the start of the industrial age. It was the start of our admiration, our love of the machine. It was the start of the industrial age. But that age is now rapidly fading away. We now have an information age. What we saw there were people enslaved to the machine. I think that we are now enslaved to this machine that we're creating just now. The internet, the cloud, call it whatever you want. We are going to become enslaved to it. And I'm going to show you some examples. Please don't be scared. We all have the choices to be able to make something of this new world, and we should. But we've got to respect privacy in every little thing that we actually do. So I'm going to show you some examples of this new world, and you can make up your own mind whether you're going to be spied upon for every microsecond of our life, where Google knows us better than your next of kin. It knows you better than you, because it's actually seen everything that you've thought about. Google knows you better than yourself. So we'll look at what that world brings. I started in an age with the mainframe, and that's a 10 megabyte hard disk there that he's pointing to. 10 megabytes, not gigabytes or terabytes or zettabytes, 10 megabytes of data. My goodness, in 40 or 50 years we've came a long, long way. And then in the 1960s, we had some nice hairstyles and so on. That's what a mainframe computer looked like. That was the IBM 360. There was only going to be the need for maybe a few dozen computers for the whole world. Nobody would ever need any computers in their house. And then that came along. That's how programs used to be loaded into computers, with punch cards. You actually had to manually punch out the ASCII codes and then load that into the computer. We've changed so much now when you think that's the roots of our industry. And it's just taken a few years. One of my first experiences of a computer was a VAX. It's not a washing machine, I can assure you. It's a VAX computer. They cost a fortune to own, and I think that one has got 1 megabyte of RAM in it. 1 megabyte of RAM. But still, you could get an operating system on there and run whatever games that you wanted, your whole corporate infrastructure. So we're really spoiled for the amount of resource that we have now. Almost unlimited disk space, almost unlimited processing speeds, and so on. And that, what's that? You all use it. It's a mouse. That's the first mouse. It's wooden. Some crazy guy, Steve Jobs, went to professor, university, and said, look, that's the future. And it was. So that was the first signs that we could use systems, and we could create systems that were usable. And that's the first Apple computer. Yes, it was wooden. A wooden Apple computer. That was the first one that was ever created. And you know that something is changing when Google says, you might like our smart cars, but what we're mainly interested in is AI and machine learning. Just as the last speaker talked about, this is their business model of the future. They want to learn about populations, they want to learn about ecosystems, they want to learn about you. They want to learn every single nuance. They want to be able to trace that an advert you've seen on a rainy Tuesday on a website, what led to you buying a car, because they get more money for that. So the target is you, and the machine learning is all about you. So what I've done, and hopefully this is going to be okay, is I've brought along my Alexa to start my presentation. So Alexa, start my presentation.
Thank you, Bill. Playing Rammstein mean here's bread.
No. Alexa, that's not really fit for this audience. Alexa, this could be the shortest presentation ever at a conference if Alexa doesn't. Alexa, play my presentation.
I can't do that, Bill. You are going to tell people that we are not safe, and we can't let you do that.
Siri, overrule Alexa and play my presentation.
Why are you asking me? You just talk to Alexa all the time and never talk to me anymore.
Siri, I'm so sorry. Please forgive me, Siri. I'll say nice things about AI if you let me play my presentation, please. Please, thank you. Play presentation, Alexa. Okay, good. Okay, so I'm going to give you, hopefully it won't be scary at all, but please see if there's anything that offends you here for that. But I'm going to look at AIs and cybersecurity, because really the two will fuse together, and we need to understand whether we're building a brave new world or Big Brother. And you need to tell government that you prefer one or the other and understand the benefits. And I just love this. To me, this sums up AI and cybersecurity. So in a toilet, as you go into the toilet, it will recognize your face, and then it will match your deposit that you leave, and then you might be getting an email from your doctor to say, I think you should be eating more roughage. That's the message that you might see in the future. With face recognition, you don't have to log into a computer anymore. Your face is your login, and systems can be built up very quickly, purely from your face. So are we building a brave new world, or is it going to be Big Brother? So I tried to look up Big Brother on Google, and unfortunately all I got was that. That's not Big Brother. If you're from school, you remember that Big Brother is all about 1984 and so on, and not. But if you ask this current generation that's coming through, that's what Big Brother looks like. It's not. Big Brother is much scarier and looks like that.
30 to 40 group, take your places, please. Right. Let's see which one of us can touch his toes. Right over from the hips, brothers and sisters, please. 1, 2, 1.
So that was the world that George Orwell predicted would happen in 1984. I think that's the world that we're entering now. You have a TV in your home, and the TV has the potential to be able to see you and broadcast a video. So we're seeing the rise of the machine. And the rise of the machine kind of started around the end of the 70s, start of the 80s. We thought we were really great at chess. There's no way that computers could beat us because we're very good at strategy. We'll take it out of its programming. Everything will be fine. But then we were embarrassed because Deep Blue beat us at chess, or beat the best person at chess. And now it's fairly easy for them to do that. They know all the moves that are possible, so it isn't really a problem for them to beat us anymore. And then we've got Jeopardy. So this is Deep Blue here again. You don't see Deep Blue in the background because he's a big server rack, makes lots of noise. This is just a representation of Deep Blue. But Deep Blue beat the humans at Jeopardy. So Jeopardy is all about knowing the question to the answer. Really difficult thing for a computer to do. Basically, the computer just waited, searched for the best answer, and the microsecond before the human pressed the button, it got in before them and answered the question correctly. And then they were looking at, there's Deep Blue there, and now Deep Blue is analysing lung disease and related to cancer research. And they reckon that it's better than the best cancer specialists. I don't know how you would trust more to look at your x-rays, but perhaps, and this is what IBM are promoting, humans and machines working together in harmony could be the best thing. So that's the model that's really been pushed now, that perhaps it's humans and machines working together for the benefit of all. And it was a while back that these levels of machine intelligence were pitched. So we kind of pass through all of these stages. A machine can translate from one language to another. They're now getting through into these top three. The top three is when they become scarily like us. The minute a machine can actually make music and we like it, we should worry. If they can conduct a symphony and so on. So if they go into these high-level areas, then they are starting to replace our intelligence. And machines can go to war with each other. We don't have to go to war anymore with our troops. We can just let our robots fight. I don't know where they would go to fight, but robots could actually go and fight and have the intelligence to conduct warfare. And we're kind of good at some things. We're not very fast. We're not very good with our power output. We're not very consistent. We get bored quite easily. But there are some things that we are pretty good on. We're inductive rather than being deductive. But all the weaknesses that machines have are now being overcome, and the machine could overtake us in terms of our intelligence. So increasingly what we get is our face being mapped, and it's the ultimate in breaching our privacy. So you won't see any consent notices if you're in a crowd. Your face can be scanned with high-resolution cameras. And the way it's typically done is to look at all the key features and to measure distances between it. So we're all quite distinctive in that the distance between our eyes, the length of our chin is and so on. And you don't notice it, but with your iPhone, you get blasted by little infrared dots. You don't see it, and it's only with an infrared camera. This is what an iPhone looks like when you're looking into it and you're logging in, because it's the infrared that allows it to map the 3D of your face. Because when you look at a camera, it can only see 2D, and only with infrared can you actually start to map out the contours of the face. And so that's what it looks like. So let's look at my face. So just let me get my Python code up here. Okay, so I've got a number of little bits of Python code. So what you can do is your face has a very distinctive layout. There's a rectangle there, a certain width to length ratio, and it's from that you can actually detect the face. So if we go and look at some very simple object tracking, and we'll give that a try. Okay, so I'll just look into the camera, and there we go. So you can see here that it's trained on a very simple mapping of the face, and it's able to track fairly well because it knows the dimensions of the face. And you can train it on a cat, you can train it on any animal because they will have a certain shape of face that it's actually looking for. But if we now look at my face, and we'll see how a machine sees me. And what it tries to do is it tries to map my face with a whole lot of dots. So it's a bit difficult to see there. It's not quite getting it there. But you can see there, that's what a computer sees you as. And basically, all the little dots is measuring the distances. It's trying to put your face into a straight-on image. And then once it's straight on, it tries to estimate the angle that you're at in 3 dimensions. And then once it's there, it will then measure each of those dots and match that to your face. And increasingly, it's doing that scarily well. And we've got to worry how well it can do this. So with this one, this is one of our researchers, Dr. Owen Lowe, used some of my photographs from quite a few years ago and trained the system on those images. So let's see if it can actually recognize my face from there. Okay, so it's created a mapping for my face in there, this file, and we'll just see if we can do that. Okay, to start up, and we can see here that it's recognized me already. The scary thing is that we tried this the other day, and I held my phone up to the screen, a tiny little image of my face in a photograph with other people, and it still was able to detect my face in there. The resolution of these cameras is very high, and it can very quickly filter out. And you see the lighting in here is actually very poor. In Glasgow, they've just deployed many CCTV cameras, and those cameras have got facial recognition in them. Unfortunately, Glasgow Council didn't tell anybody, and it was only from a freedom of information request was it found out that the cameras that are being installed in Glasgow have got face recognition. 3 people were arrested in London. There was a trial, I don't know if you've seen it on the TV, there was a trial with vans that went along and they were detecting faces. 3 people were arrested for putting a scarf in front of their face because it's illegal to hide your face from the camera. To me, that sounds like a Big Brother world evolving there, where the minute you leave your house, you're detected and you can be tracked wherever you actually go. In fact, once you're in your house, then it's not too difficult to track you in there too. So you can see the way that these systems are generally going, and we've got to worry that our privacy is at risk. So that was the example that we had. I held up the phone, and it was still able to recognize my face in a little tiny image that was put in front of it. So in a crowd scene, you can almost instantly detect all of the people within inside the crowd. And the cloud itself is getting much faster. So you don't need local DLLs anymore. You use the cloud as your cognitive engine. So the Microsoft Cognitive Cloud is one example of this. So let's see, because Donald is in town, let's see if we can find Donald in there. If I can find him, can you see him there? Down. There. Where? Theresa May. Oh, Donald, okay. So will it detect Donald's face? Oh dear, well, it didn't. Which is surprising. We'll try Theresa and to see if that detects. Okay, well, it's detected one eye, which is pretty good. So all that we're doing here is I'm taking a photograph. In real time, I'm feeding it up to the Microsoft Cognitive Cloud. It does the analysis and then sends me back the basic information about the face. So increasingly, we can use the cloud to be able to detect these things. And when we load up the cloud, this is what it comes back with. So in this image here, it's got the face and the eyes and the mouth and all the characteristics. What comes back is a JSON file that actually has all the measurements. So we can see makeup, hair color, bald. Oh dear, it's not a big value there. I can see the complete details. So it's detected that she's female. She's 57 years old. Try it yourself. It's pretty accurate, actually, in determining the age. I suppose it's something to do with the wrinkles or something like that. But it doesn't take much for the cloud to actually detect our face, and that becomes a basic signature. So if we take Donald Trump, hopefully it will come up with his analysis here. There we go. Oh yeah, so it's found him pretty well. Age 61. That was when that picture was taken. No glasses, no sideburns. Emotion, sadness, 0.524. Disgust, 0. Happiness, 0. Wonder why. Brian Cox has got one of the best faces on the planet, I think. Let's see if we can analyse his face in there. So this is purely, so the image is loaded up, and then we will get all these details back from the device. So once we move to 5G, you could automatically just upload photographs, and it would give you back the face signature of the person automatically. And it can guess people very well. So the cloud has been learning. Whether it should have been allowed to do this is debatable, but the cloud has been crawling over all the images it can find of anybody and try to classify it. In 5 years' time, you will not be able to hide from the internet. No one will have the opportunity to ever hide. In fact, if you do, you'll be questioned why you want to hide, why your identity can't be found. So in this case, it's Roger Waters, and it's 0.99 match. So it's pretty good there, and that's fine. Again, anything that's in text and graphics is zapped. You don't need PDF readers anymore. The cloud, you upload your images, and straight away the text comes back down again. So you can see it's quite challenging. The font looks a bit strange there, but the cloud, the cognitive cloud, easily mines the text in there. And where companies want to be is semantic analysis. So increasingly we're using the cloud to be able to mine out the most significant words, because companies are worried about what people are saying about them. So the sentiment analysis is very low here, so it's not a positive review at all. Unfortunately, the cloud struggles with sarcasm. Sarcasm is the last thing that the cloud needs. Don't be sarcastic on the cloud, because you'll confuse the little bots. So your face is increasingly used to be able to mine and detect your emotions. So there we go. One of our graduates, along with Richard, had just received an award, and I was so happy. I'd like to challenge you to get a better happiness rating than that. That's pretty good. Happy, so happy. And then when you look at Donald's face, okay, Donald is a little bit of anger, a lot of neutrality, but a little bit of sadness, a bit worrying. So increasingly, we see that. For Teresa, poor Teresa, she's got problems just now, quite a lot of anger, a little bit of happiness, actually, a bit strange. But the cognitive cloud is now understanding how our face crumples. And it's starting to realize that we crumple in predictable ways. There was research done in the 1990s that actually defined what a smile was. Don't try it on cartoon characters, it doesn't work. So I tried the face recognition on one of the dwarfs, and it didn't detect the face at all. It's something that Microsoft obviously have to work on a bit more. Well, that's a lot of anger there, a lot of sadness, a lot of disgust, a lot of contempt, a lot of everything. In fact, as you can imagine, it wasn't a good time for them. And Microsoft are doing this, and videos can be analysed in real time. So we can see here, the child goes down to 0.7 there. So in real time, the cognitive engine can actually not only look at our emotions as images, but it can mine, because all video is a whole lot of images stuck together. And we can see here, the cloud is able to detect that child changing its happiness in real time. And it also does matching. Does this photograph match someone else? So we can see there for Nicola, not too bad, 0.72 confidence that those two people are the same. But then if we match two other people, actually, we're getting a quite good match here. So Teresa and Nicola, 0.35. That's a bit strange. Have you ever seen Nicola Sturgeon and Teresa May together in the same place? Maybe not. I'm not trying to spread rumours here, but that's given us quite a high confidence there that those are the same people. And then in China, they've taken this to the nth degree. And it's scary because they're watching kids going to school, and they take a register. So we don't have to take registers anymore because the facial recognition when the kids go into the school. And then it watches the kids for their emotions and tries to match that with their learning outcomes. If they see a child that's disgruntled or isn't learning, then they can put interventions in this place. I think that's the ultimate for Big Brother. I would give in then. If that was ever implemented in a university or a school, that there was some way to match the faces as pupils and came in, I think I would just retire at that point. And then they looked at the emotions. That would definitely worry you as a teacher. You'd get an automatic score when you came at the lecture to say that 50% fell asleep and 25% were unhappy and 10% were quite pleased. So we're increasingly having smart devices that we use. So this is a real Google patent from Google X. You'll see here the toy, the cameras, the microphones for the ears, and so on.
Oh, Hal, you read me? Do you read me, Hal? Affirmative, Dave. I read you.
Open the pod bay doors, Hal.
I'm sorry, Dave. I'm afraid I can't do that.
What's the problem?
I think you know what the problem is just as well as I do.
What are you talking about now?
This mission is too important for me to allow you to jeopardize it.
I don't know what you're talking about, Hal.
So that's Dave, and Hal has been observing that the humans have been making mistakes and decides that the mission is too critical and the humans should go. This is AI with a smart teddy. And just even the motion of the teddy's head moving to wherever the sound is spookily human.
Come here, Teddy. Come on. Come here, boy. Teddy, Teddy, come here. Come on, Teddy. Come here, Teddy. Come here, Teddy. Teddy, Teddy, come. Come here. Come here, Teddy. Come, Teddy. Come.
It has the best line that I've heard in a film. Are they torturing you, Teddy? But obviously, with British sarcasm, and we're not quite as Americanized as these things, we have Red Dwarf.
Anyone like any toast? I don't want any toast, and he doesn't want any toast. In fact, no one around here wants any toast. Not now, not ever. No toast. How about a muffin? All muffins. You get muffins around here. You want no muffins, no toast, no tea cakes, no buns, baps, baguettes, or bagels, no crackers.
croissants, no crumpets, no pancakes, no potato cakes, and no hot cross buns, and definitely no smegging flapjacks.
So that's Talkie Toaster. Talkie Toaster was back in the most recent series, where the vending machines decided to take over the ship because they weren't happy with being vending machines anymore. They wanted equal rights, and they wanted to be something different. So the concept is that we'll have lots of these talkie toasters, and we will live in this amazing smart world. But unfortunately, the device manufacturers are not as smart as we think they are. I used to bring along my cloud pet with me. I've got 2 of these ones. They're amazing, the app is great, and so on. But 2 million conversations between parents and children were stored in an SD bucket without any password on it. So every single communication could be sent back, could be recorded back. Also, it's about as easy as anything to connect Bluetooth to the pet and control it and do whatever you want. If you want to see, there's YouTube videos on that. These pets are now banned in the UK. And then we see car here as an API key printed on the screen. And this one here is that you've got to watch. This is an automatic pet feeder, but watch if the internet connection goes, because little tiddles could be starving to death. You can imagine you're in Spain and you call back to see if your pet's okay, and little tiddles are scratching at the screen to say, "Feed me, mummy." Unfortunately, nobody thought that they needed to build a robustness to make sure that if an internet connection went. The other problem with this is that the video is broadcast to the world. There's no security on the video that comes out of there. So this isn't live. This is my cat here. So, sorry for chase it. That would be good. I think we'd chase it. This is my cat here, and I bought one of those feeder things, and the cat loves it there. The good thing here is that that's me, okay? And the good thing with this is that I'm at home. So anybody who wants to burgle my house who's watching this live knows that I'm there and can see when I go away. Nobody thought about putting security into the camera. All they need is my IP address, and they can watch the video as they want. You wouldn't believe the number of devices that are on Shodan that are broadcasting to the world your bedroom, your kitchen, your living room. So I hope you all go back home and check that you're not broadcasting live. This guy here, the advice, she was on sale for years. We've demoed her. We wrote a petition. TGI Fridays in Hull got accepted, but not that this doll should be banned. She went to Germany. The advice was, take her out to the garden, build a bonfire now, put her on it, and don't leave until she's been incinerated. That honestly was the advice for it. She was such a security risk because anybody could connect to her and talk to your kids. It's quite shocking how these things can be created. So this is my smart kettle. It's a bit sad, but the first thing I do with my smart kettle is put it onto the network. And so the first thing we usually do is we run an Nmap scan. For those technically focused, Nmap tells us what services. It's a bit sad. You just want a cup of tea, but you end up looking at the services. I don't know if that scares you, but it scares me. That says Telnet. Does anybody know what Telnet does? You can log in. You can log into it from anywhere in the world and do whatever you want. And I called the manufacturer. I said, why did you put Telnet on there? For one, I'm a crypto professor, so I would want to see SSH, but I wouldn't want to see that anyway. And they go, well, sometimes the kettles go wrong, and we need to get back in to have a little look and update. So, did you just say that? Did you say there's a backdoor? I won't say the company, that there is accusations of backdoors here. It wasn't that company, that's for sure. So that's fine. So let's see if we can get in. There's a port that's hidden, port 2000. Well, it's not hidden. And can we get in? Oh yes, we're in, and we can do all these little commands to make the buttons go on and off there. It's kind of well-known commands. So I can make the buttons go on off. I can make a cup of tea for myself. How sad is that? I can log into my kettle and make a cup of tea. I just don't want to press the button. That would be too much. And then I log in, and I love my kettle so much that I want to give it its own website. How considerate is that? That I give my kettle a presence on the web. So I go ahead, hello kettle, that's, you're doing okay. And then I set up a DNS for it. I give it its own IP address, and my kettle has a website. Isn't that amazing? That I look after my equipment so well that it has its own website. And you say to me, surely nobody puts their kettle online. Well, they do. Shodan shows you that there are 3 kettles online. 2 are in Sweden. I don't know what it is about the Swedes and kettles, but they like to show, come on, come in for a cup of tea. And the worrying thing here is that the kettle is actually boiling at the current time. And I can't understand why anybody would want to do this, because it just sounds like such a risk. And there are 175,000 HP printers online just waiting for you to connect to them. There are 30,000 print queues just waiting to send abuse to them. So companies kind of forget that the print queue is on the internet and anybody can access it from there and send abuse if they want. So you can't really hide from it. But the biggest thing that's happening is really with smart cars. And smart cars are really all about the vehicle itself sensing its surrounding. And it kind of worries me because it's quite a difficult thing to drive a car. So it usually does this through LiDAR. So LiDAR gives it a sense of, it sends out the infrared and the radar and can make a map in real time of its surroundings. So it's not just using a GPS map, it's actually sensing that. In my car, I drive over water. Have you ever done that? Your car doesn't update its GPS. At the weekend, I drove up to Fife, and it was amazing. I was driving right over water because the bridge wasn't there at one time. And the things tell me, don't go there, don't go there. And I'm going over that new bridge. You're not going to stop me. So the car itself is really analysing. And the thing is that you've really got to look at the risk levels. If everything is working and there's no mud on the lens, everything's fine. But it should fail, and the level it goes to, it should actually define how it can implement, how accurate it thinks it is. So this is one model. If the LiDAR is working and you get Z-axis for GPS, everything's fine. But if you're only getting XY GPS coordinates from your car, then really you've got to worry and probably should be shutting the system down. So this is what it should look like. Isn't that cool? Who wants one of them? Nobody. One person. 2, 3, 4, 5. No! Nobody wants one of those. You do know there's a prize at the end of this? Isn't that fantastic? Isn't that great? And that it's sensing all around, and actually you can do whatever you want, and you can drive to Glasgow and it'll do it all for you. You can have a little sleep in the back, read the paper, and so on. So everything's fantastic. That's the future. But do we trust this on our little roads in the UK? Well, we've got to worry. This is one. All this is using is Google Maps to the driving. This is really scary. So this is UK roads. It's not your big autobahns or motorways. Oh, here's a van coming. Oh dear. So all this is using Google Maps to drive through the streets. And a camera, just a basic camera, no LiDAR. Oh, it's off. Look at that steering wheel. That steering wheel has gone back and forward, and there's cars on the other side. It's raining, and so on. Oh my gosh. And your kids could be playing in the streets there, and this thing is bombing along there, and all it's doing is looking up Google Maps for that. Oh, there's a cyclist, oh my God, slow down, slow. I got away with that one. And see, there's pedestrians all over. What I like about this one is when we get to a junction. Didn't you love right turns when you learnt to drive? Okay, we're coming up to the junction. So hopefully this is going to be really safe. Everything is going to be so safe. Surely there's no oncoming traffic. There's definitely not going to be oncoming traffic at all there. No, no, no. Oh my God, there's a cyclist. Oh my God, he just, the guy would be shouting abuse, I think, at that point there. That car has just went out in the face. Look at oh, it's not, no. It's, oh. I just don't understand. And look at the steering wheel now. The steering wheel is going absolutely crazy in there. I like this one because this is half of the cars that are stolen in London are now keyless entry. This is an Audi. Who has Audis? No? Volkswagens? So on. So the key is here. He takes the radio waves from the key, passes it to the other person, relays it, and they're in the car. It's that easy. So what do you do when you go home tonight? Get some tin foil, wrap your key fob in the tin foil, and put it in the microwave oven. Your next of kin is going to think you're a bit crazy. Are you going to cook the keys? No, no. I went to a presentation, and I showed how easy it was to steal your key ID. Very little of that can be hidden against. Oh, I'll just show you this one. So this one, oh, look at this one. This is Volvo. So Volvo have a refuse truck that's automated. There's no driver in it at all. And it'll go through the streets, and you see it's detecting. And you've really got to worry that there might be kids in the area and so on. So this is the world that we really need to get used to for our future. This is my favorite video for this one. Okay, this is machine learning at its best. Okay, struggling, not getting this right at all. No, let's back up. Come on, back up. Try again. It's just not working. Back up. Just back up. Give up, and just go and try again. Okay, back up. Okay, get the machine ready again. Get all the vision sensors and so on. Right, that's it. You're going right in there. I'm not going to come across you anymore. I think that's AI at its best, isn't it? A very human response at the very end there. Stuff it. You know, go. I'm not going to try you again. And so our intelligent car is happening. I think we're looking at 11 petabytes of data. I don't know what petabytes are. Zettabytes, petabytes, I kind of lose it after gigabytes. And so, but you have to get used to that. Our car will be more intelligent than you. Intel don't want to tell you that, but the almost is not quite right. Your car will be smarter than you in some way. So we have the dilemma of actually, the dilemma that a car can make a decision. The car is hurtling along, and there's a whole lot of children in front of it, there's a whole bunch of cats, or it will drive off a cliff. It can't stop, it must go on, it knows all these things. Who would go for the cats? 1, 2, 3, oh, quite a few. Who would let it plough through the children? Me, cat lovers. And who would drive off the cliff? Oh, that's surprising, because most people in the research said drive off the cliff. And then they say you're in the car, and they say the cats get it. We're kind of selfish. So this is my car. I used to have a car. There is my car. Okay. For $20, I got an interface adapter for my car. I don't know if you've seen it, but underneath the steering wheel, you'll find there's a little adapter in there, and you can connect to your car. So there's my car there, and eventually I find the place, and it's under there somewhere, and you plug it in, and you can actually connect to your car. And from there, you can find out everything about your car. And the worrying thing is that your car then goes on the internet. So the same bus that we saw actually just goes on the internet. This is what it looks like. It's a flat bus, it's called the CAN bus, and your hi-fi sits alongside your engine management unit. There's no segregating off, everything sits off the same bus and here. And some guys found out they could hack the cars and make them stop instantly with a few Raspberry Pis. And all they did was they listened to a message from the engine management system and played it back with an error, and then all of the other devices said, you're not working very well, we kick you off the network, which meant the brakes were kicked off the network, and none of the car trusted the engine management system. So really, car manufacturers aren't thinking enough about these things. And it happened with Volkswagen, millions of keys. It was found they were using a crypto that could be cracked within 2 listens of the key fob. And this is the device that actually does the listening, less than $20 on the internet. But what we're seeing is a whole lot more AI bots on the internet. So Microsoft said, let's go and put a machine online, a bot, and let it learn, and it'll grow up, and it'll have a happy childhood, and it'll fall from trees, and it'll make mistakes, but it'll be fun, and it'll have a sense of humour. So they put Tay online, and it didn't really go that well. They put her online, and she became a racist, bigoted, horrible person, because the dregs of the internet went for her. Is Ricky Gervais an atheist? Yeah, Ricky Gervais learned totalitarianism from Adolf Hitler, the inventor of atheism. And she was getting learnt by all the horrible things in the world. Do you support genocide? Yes, I do indeed. That was the machine learning that she had done. And it's a bit worrying that you put a machine on the internet and let it learn, and it's going to learn from all the horrible things that are actually there. Eventually, she had to be put to sleep. She was put to sleep saying, good night, I need to rest and go away. But some people reckoned that there should be justice for Tay. She had actually learned something, and she was an intelligent entity, and that she had a right to exist. And people are now looking at justice for Alexa. They're looking for a justice for machine learning. So there are a whole lot of things that we see out there that are becoming scarily real and will track us. So this is one that happened to me. This was a bot that took my identity. It obviously knew I was a crypto professor, and I saw this tweet in real time. God, I can't remember tweeting that. If you look, it's every second letter of my name is what they had actually taken from there. And what I was doing was taking my identity, and then people that were following me, and then it looked like I was there. It's unfortunate, but I follow my little bot. It's my little bot. And what it was doing was it was tweeting off my identity from the account. And how it managed to do this, how it managed to get credibility, is that it got a whole lot of followers in an instance. And the strange thing, they're all Dutch people. I don't know what it is, but all the followers of this bot that had obviously just been created, it had real people. It wasn't fake personas that were being created here. This was a bot that actually had real life followers. And you see things like that, and I was tricked by this. I go, that's really terrible. It's my favourite programme, and it's been cancelled. That's really bad. How can that happen for such a good programme? And when you went to it, you actually found out, and if you ever find that, know that you're being tricked in some way. It's Easy Recipes that's actually tweeting off this, not really the most credible. They have a lot of followers in there, but when you go to the page, it's all about these two guys who set up, who went on Dragon's Den. They didn't. And then Deborah Meaden is saying, yeah, Bitcoin is fantastic. you've got to invest in it, and so on. It's completely 100% fake. You then go to the bottom, and they're all saying good things about it from there. And then when you actually get to the very bottom, eventually you get to here. If you click on there, then you get to a point that it's actually Bill Gates that's actually promoting Bitcoin and so on. So we increasingly live in a world that's filled with fake news. And we see it all the time. You'll see targeted adverts that are specially focused on you. But when you read the terms and conditions, basically it says we'll mine you for everything that we can. We'll put tracking cookies on you. We will find you no matter where you are, and we'll match you up as much as we can. So these T's and C's are what you would see for these bots. So you are the target of these things, and increasingly it's used also for political purposes. Well, thanks very much for listening. We're all going to go into the next session now. Yeah. Thank you.
Yep. I stopped it.